Standard 3 is analyzing the spatial organization of people, places, and environments. Spatial organization is very important in today's world, particularly in the planning sphere. Geographers and planners apply geography. They ask questions about the world: where, when, why, and how. And they look for answers to critical questions about the past, about the present, and certainly about the future. Spatial analysis is a powerful tool for examining the world at all scales, on the micro level in municipal governments, in state governments, federal governments, and even international governments. The ability to describe and analyze the spatial organization of people, places, and environments is highly important in the world today. The picture on the right shows a number of people looking at a city map or a regional map. They could be asking questions like, how do we rerun a stream that tends to flood in particular neighborhoods? How do we change its channel without damaging the environment? They might be asking questions about where they might build a new school, a new elementary school. They might be looking at other questions involving traffic and transportation routes, or other kinds of linkages that make a community more cohesive and run more efficiently. There are many, many questions that people will examine around spatial organization. The picture you're looking at on this slide is showing us ancient trade routes in North America, Canada, the United States, and Mexico. What you're seeing are American Indian trade centers, copper mining centers, obsidian mining centers, and other minerals as well. More importantly, what you're looking at are the trade routes and the linkages and the connections and the interactions among people in this hemisphere. This is a very early beginning of what we can talk about as spatial organization or spatial analysis. The previous slide we looked at showed us ancient Americans' trade routes in obsidian, copper, and other minerals. This particular slide that we're looking at now gives us a whole new perspective on the trade routes of the American Indians. This one is showing us trade routes and the spread of infectious diseases, more than likely across the same paths that we saw in the previous slide. So analysis of prehistoric and historic trade and exchange networks provides insights into the possibility of Old World infectious disease transference and diffusion prior to European contact. Transference and diffusion to geographers are important key words. How have things been transferred from one place to another, from their center of origin to other centers? How have they diffused, meaning how have they grown and moved from one part to another, sometimes across continents? Both of these terms are geographic concepts that arise again and again in geography. By showing the existence of established trade routes and exchange networks dating back into the prehistoric times, the possibility is greatly increased that these trade networks acted as access corridors in the pre-contact diffusion and transference of many Old World infectious diseases like smallpox, typhus, measles, and others. So here again we can see how we can apply geography. We can look at ancient trade routes, look at major infectious diseases today in this continent, and we can make some connections how they might have transferred and diffused from places of origin along these trade routes. To engage in spatial analysis, one has to become geographically and spatially literate. To do that, geographers identify features and structures and human activity on Earth's surface. We can look at 4 different realms. The physical environment, we look at topography, the hills, the valleys, the mountains of a region or a place. We look at streams, rivers, and lakes and other water sources in an area. Climates are important, as are vegetation types, soil types, and other questions that have to do with the physical world. Human features might include the towns and cities that people have built, ancient cities, modern cities, and future cities. We look at population, rise, decline, and migration to and from a particular place. We look at highways and other trade flows and networks. We might look at the spread of diseases like you saw in the previous slides. We might look at the development and growth of national parks throughout the country as population has demanded them. Perhaps more importantly, we take the physical and the human together. We look at, for example, a beach resort in relation to the climate of the region, a physical feature, the topography of the region, another physical feature, and major population centers or cultural innovations in the area. And then we look at location and arrangement of both the physical features and the human phenomenon, and we look at what kind of patterns they form, what regularities are there on the landscape, maybe what irregularities. We look at patterns and recurring patterns in analyzing our space. In this picture, we're looking at a map of Duluth, Minnesota, and Superior, Wisconsin, at the very westernmost edge of Lake Superior. Duluth and Superior have long been very important hubs or nodes for transportation, shipping transportation as well as railway transportation in the United States. So what we're going to look at in this slide is the description of a pattern of spatial organization by breaking it into very simple components. We'll look at points, lines, areas, and volumes. These four elements describe the spatial properties of objects. For example, a shipyard that we can see in both Superior and Duluth can be thought of as a point, an actual place. The shipyards are connected by shipping lines and rail routes. These are the lines. Then, these shipping lines lead to nearby markets as well as faraway markets, and they also lead from nearby iron ore mining sites. Those are considered areas. And then the lake, the Great Lake Superior, can be thought of as a volume. In this slide, we're going to look at the concepts of location, distance, direction, density, and arrangement. In terms of arrangement, we can look at linear arrangement, grid-like arrangement, random, circular, or others. We can look at the two maps on this page. The U.S. interstate highway system can be described as a series of lines. These lines are connecting points over an area, the United States. The arrangement is partly grid-like, with north and south and east and west routes, and it's partly radial or star-shaped or even spoked, as in the highways centered on Atlanta. And the pattern of the interstates is denser in the east than it is in the west. That's what you see in the top map in the picture. Just a slight switch on the theme, in the bottom map, we also see the interstate systems, but the focus of this map is the bottlenecks that occur on the U.S. interstate system. You can see that it's probably partly connected to the denseness of the population in the eastern portion of the United States, and you can also see that most likely in major cities, even in the West, we have more bottlenecks. This is a great map to show us the concept concept of human as well as physical elements taken into consideration when planning or organizing or analyzing a tourism city. This is a fairly complex map, brightly colored map, that you might not pick up if you're a tourist in a particular place. It's not going to be that useful to you. However, if you're an urban planner or a city planner, you're going to be looking at several things on this map. What are the best zones and regions for tourism in this particular place? What are the amenities that people are going to be drawn to? What are the transit road routes? How do people get from one place to another? What are the transit water routes? How do these connect our various amenities and various recreational centers? Or how may they cut off a route, a road route that may need a bridge built around it? Where are the airports? Where are the other tourist centers? Where are other amenities like spas and other places where tourists might like to frequent? All of these are taken into consideration as city planners try to develop a city and make it more accessible and more amenable to tourists. This slide is showing us how spatial analysis can actually be put into practice, in this case, developing safe routes to school for children. The walking route plan helps to identify where improvements are needed and where to place crosswalks, stop signs, and adult school crossing guards. The ultimate purpose of the walking route map is to encourage more children to walk to school and discourage parents from driving their children to school. What's great about these maps and these projects, is that it involves students, it involves parents, it involves school officials, and it involves city officials. The school provides the boundary map and parent volunteers to work on reviewing and developing the walking routes. The city provides aerial photographs, quarter section maps, and guidelines for parents and school officials on how to conduct their reviews. The whole process requires parent volunteers or school officials to review the entire walking route and to identify the most desirable walking routes to serve each household. Once the walking route maps are completed, traffic officials review the area of concern and work with school officials to assure that the right number and placement of adult school crossing guards exists. The city provides final versions of the maps and maintains the computer files for the walking routes for easy updating. It is the responsibility of the school officials to distribute the walking route plans to the parents at the start of the school year and when new students are enrolled at the school. School walking route maps are reviewed annually to identify if there are any changes to or within the school walking attendance boundary. This slide is showing us the trucking network in the state of Vermont. Here we can look at questions of spatial organization, such as movement and flow. In this case, the movement and flow of goods from one part of Vermont to another, and, of course, beyond the state of Vermont. We look at the concept of diffusion, the site of origin and its spread. Where does something begin and where does it move? How does it diffuse? We look at the concept of the cost of distance. Most firms, as they're profit-based, are going to want to move something for the lowest possible cost, the most efficiency, the fastest way to get it there, the least amount of gas. We can also look at questions of hierarchy, large urban centers down to small towns. Where do you suppose trucks will stop more often? Probably in large cities where they can drop off more goods or pick up more goods. We look at the concept of linkages. How do trucks move from one city to the next city most efficiently? And accessibility. What's the easiest route to arrive at one place or another? When you're looking at this map, what you can see are a variety of roads. We have the blue lines, which are national networks, yet they have limited access for trucks. The red roads are showing truck networks that don't need any permits. The green roads require a permit. There are yellow areas around certain roads that show trucks where they should avoid travel. These are generally urban areas. Trucks want to go around urban areas rather than through them for efficiency. So looking at these maps can help us explain the patterns and the functioning of transportation in Vermont. Geographers and planners today place a great deal of emphasis on spatial organization that includes the concept of functional regions. Functional regions are areas that are defined by business and economic activities. Functional regions are organized around a node or a focal point, with the surrounding areas linked to that node through systems, associations, and activities. In this case, on this slide, we see a map with an airline headquarters and all of its flights that originate at that hub or at that node, at that focal point. The concept of functional regions provides a way for geographers and planners to examine the linkages and flows that create interdependence among people. This slide is showing us a map of an area with several identifiable physical features as well as human features. From the left-hand upper corner, we can see some natural boundaries, the mountains, which also are open space since they're not developed. Moving to the upper right-hand corner, we can see along the edge of the area some man-made or human-made boundaries. Moving around the map, we see a regional service area. We see a core at the center of the map. We see some neighborhoods, and circled, we see a community service area. This model of planning suggests that cores be created at neighborhood, community, and village levels. Some reason for creating cores in neighborhoods is to encourage a more densely settled pattern of living. That is, the more people living in close proximity to one another leaves more hinterland space that can be left as open space and preserved. Another reason for creating cores is for community cohesion. Sometimes in the United States over the past couple of decades, we've heard that people don't know each other. So the purpose of having a community core is to create perhaps a more walkable, more accessible part of a city so community members are able to participate and engage more in civic affairs. In this map, we're looking at the Great Lakes. We're looking at relief, drainage, and urban areas. In the case of a physical pattern, such as a river or a lake system, there is a complex hierarchical arrangement linking small streams and lakes with drainage basins and large rivers and lakes with drainage basins. Like other regions, here we see the spatial and human relationships, linkages, and networks that operate in the Great Lakes region of the United States and Canada. In this slide, we see the Mississippi River drainage basin. Without question, America's greatest river, the Mississippi, like the Great Lakes region in the previous slide, has made many great contributions to the physical and economic growth of this country. It is what we call a navigation artery of great importance to our transportation system. Some of our earliest transportation was conducted by riverways, before cars, before trains. Rivers carry an enormous amount of commerce. Cities are also supplied with water through this gigantic river drainage basin. Industries and towns have long been located along the banks of rivers. This slide is showing us the North American rail network. Some keywords and concepts that we should think about as we look at this map are transportation and communications. As with the U.S. interstate map, we can see how transportation and communications are very, very linked. If there is transportation routes, that means there's access for people, for trucks, for ships, for railways, to move about from one place to another. And where there's movement of people, there's also communications. We can also look at this map and we can see that the linkages, the interdependence, the nodes and the hubs. We can see where there's a concentration of railway lines emanating out from larger cities or areas of shipping and transport. Especially take notice of the Great Lakes and how dark and dense the railway lines become in those regions. Here again we see density patterns. The eastern portion and the central portion of the United States has a great number of railway lines, while the western portion and into Mexico and Canada we see fewer and fewer lines. So central to geography is the belief that there is a pattern, regularity, and reason to the locations of physical and human phenomenon. Spatial relationships, spatial structures, and spatial processes are simple to understand, although they may look unfamiliar and complex. For example, the spatial organization of human settlement on Earth's surface is generally a pattern of a few large cities, which are widely spaced, and many smaller towns which are much closer together. A comparative analysis of those cities and towns shows that cities offer a wide range of goods and services, whereas small towns offer fewer goods and services. Taken together, the description and the analysis explain why customers shop where they do, why they often buy different products at different locations, and also why changes occur in this. In the maps on this slide, we see transportation planners' vision for their particular region. The core functions of public transportations are to connect people to jobs. Do people drive in cars? Do they get to their jobs in buses? Is there a light rail? Are there other forms of transportations people can rely on? Another core function of public transportation is to connect people to major regional activity centers. How do you arrive at local malls, at local downtown centers, at local airports, or other service areas? Another function is to connect people to local activity centers or recreation centers. The focused growth transit vision, in this case, will be connected with a high-quality, well-balanced, fiscally responsible public transportation system. Some fundamental questions we might ask in spatial analysis are the following. Why are certain phenomena located or centered in certain places? We also might ask, how did those phenomena get there, and why? And we might ask, why or how is their pattern of origin, evolution, and development significant to us? In conclusion, the description and analysis of patterns of spatial organization must occur at scales ranging from local to global. As students and educators, we confront a world that is increasingly interdependent. And widely separated places are interconnected as a consequence of improved transportation and communications networks. and probably most importantly, because human decisions at one location have physical impacts at another location. Just one example of that is the decision to burn coal rather than oil in a power plant may result in acid rain damaging vegetation in a location hundreds of miles away. Therefore, analyzing our space and the space around us is a very important geographic activity. This lecture was presented by Elizabeth Larson, Lecturer, School of Geographical Sciences and Urban Planning at Arizona State University.